Hi, I'm Vanessa Walker once again from AFD, and I'm here to talk to you about something that we deal with routinely in the pharmacy. And when you go to take the pharmacy technician certification board examination, or you take the accept examination, one of those credentialing examinations, you're going to have to know how to do this. Um, the subject matter that I'm speaking about is dilutions. When you have a stronger strength of something, you want to make a weaker strength of it. Same ingredients. How do you go about doing this? Well, there's a couple of methods that I can think of right off the top of my head that will facilitate doing this. The first one we're going to talk about tonight, and this is the quantity times strength equation. All right? Now, very simply, you should have a simple thought in your mind to begin with, and then we'll build upon that. Okay? The simple thought that I want you to have is that what you have is what you need. What you have is what you need. Now, I'm going to state this equation, first of all, by putting have on one side and need on the other. Now, what you should know about this equation is that it says the quantity times the strength of what you have equals the quantity times the strength of what you need. Or very simply put, the quantity of the first solution times the strength of the first solution equals the quantity of the second solution times the strength of the second solution. Very simple. Now, the application of this, usually when you are seeing this type of equation being used, it is being used to solve a dilution word problem. And you're going to have to know how to do these. Now, I have a very good example of one right in front of me, and I'll read it to you. It says, how many milliliters of dextrose 25% and how many milliliters of water should be mixed together to compound 1200 milliliters of dextrose 10%. Now, in this equation, this quantity times strength equation, it is implied that you're going to be diluting with something. Now, the something that you dilute with doesn't do anything else but dilute. It is a benign substance. Now, a lot of times, if it is a liquid solution, it's going to be water. Okay? If it's an aqueous liquid solution, it's going to be water. If it is a solid solution, it may be something like an ointment. It may be something like an ointment base or white petrolatum. Okay? Now, so the first equation, the first problem that we're dealing with is a liquid problem. I'll read it again. How many milliliters of dextrose 25% and how many milliliters of water should be mixed together to compound 1200 milliliters of dextrose 10%? Now, this is the way that I would go about this problem. The first thing I must do is I have to identify it as a dilution problem. I've already done that. The second thing that I must do is I must select the method that I'm going to use. I've already done that too. I'm going to use quantity times strength. Now, my third thing that I must do, if I'm going to use quantity times strength, is I have to set up my equation properly. The wrong equation will give me the right answer to another problem. Okay? So we want to make sure that we set up the right equation for this problem. Now, I'm going to say that my 25% solution that I'm starting out with is going to be solution 1. Okay? And my 10% solution that I have 1200 milliliters of is going to be my solution 2. So that it becomes very simple at that point. Because what I do is I say 25%, which is my strength. It's going to be multiplied by Q. I like to use Q because it reminds me that it's a quantity. If I'm looking for a strength, I like to use S. Okay? Equals. My quantity on this side is 1200 milliliters. And my strength is 10%. Okay? So I have 25% Q equals 1200 milliliters times 10%. At this point, I have to get Q by itself. That's my whole objective. My whole reason for doing this problem, okay, is so I can find out what Q is. Now, because Q is multiplied by 25%, what I must do to get it by itself is divide it by 25%. Please note, I said divided by 25% and not by the number 25. It is multiplied by the entire quantity, 25%. So that's what I have to divide by. Whatever I do on this side, I have to do on that side. So let's work through this. So I'm going to divide by 25% over here. When I do that, my 25% cancel off. Over here, I'm going to divide by 25% also. Many people, when they see percents in the equation, they start to get antsy, okay? They start to get nervous and scared. There's no reason to get nervous and scared. You don't even have to deal with them because they cancel out, okay? So on this side, I have Q. That's the only thing that's left standing. Equal to 1,200 times 10, which is 12,000, divided by 25. Okay? Now, my units, after I figure out what this is, my units are going to be milliliters. Okay? That's the only unit that's left standing in this equation. So 1,200 divided by 25 just happens to equal 480. Okay, we know our unit is milliliters, but I'm not done because I have 480 milliliters of something, but I haven't identified of what. So I go back to my original equation and I see that Q is multiplied initially by 25%. So my 480 milliliters has to be of 25%. I'm still not done because in my problem it's stated, excuse me, how many milliliters of dextrose, 25%, and how many milliliters of water. I have not found out what the water is. So the way that I do that is if I know, let's think about this for a second, because if I know that I have two ingredients that make something up, all right? If I know the value of my total and I know the value of one of those ingredients, can I find the other one? Of course I can. And the way that I would do that would be by subtraction. So I take my total amount. What I'm going to end up with is 1,200 milliliters, right? So I say 1,200 milliliters minus, because I know that 480 milliliters is already accounted for. My 480 milliliters, we've already said, is 25%. So that's already accounted for. So I take 1,200 milliliters, subtract 480 milliliters, and what I get is 720 milliliters. This 720 milliliters is of my sterile water. This plus this. Yeah, I'm kind of messing up there on my little blocking off. Okay, 480 milliliters of 25% plus 720 milliliters of sterile water. When I add those together, I'm going to get 1,200 milliliters of 10%. And that's how you would work this type of dilution problem. Go on to dilutions number 2, quantity times strength number 2. We will go on to another problem, and I'll show you the process for a different problem and show you how to apply quantity times strength for that one. So I welcome you back again. If you are a pharmacy technician and you are having difficulty in the area of math, you can contact me at vw@afti, APHTI.com. Once again, that's vw@afti.com. See you later.